Have you ever wondered what is happening beneath the surface of our vast oceans? What if I told you that they are becoming more acidic? Yes, that's right. Our oceans are undergoing a process known as ocean acidification. But how do we measure this? Well, scientists use a scale called pH to determine the acidity or alkalinity of the ocean's water. Over the years, they've noticed a steady decrease in the ocean's pH level, indicating an increase in acidity. Now you may ask, why is this happening? Our oceans serve as a massive sponge, absorbing about a third of all the carbon dioxide present in our atmosphere. When this carbon dioxide dissolves in seawater, it forms carbonic acid, which increases the water's acidity. So you see, our oceans are silently fighting a battle against acidity. Now you might be thinking, how does this all work? It's actually a straightforward chemical reaction. So, let's break it down. Picture this. Carbon dioxide, a gas we're all familiar with, and one that we produce in vast amounts, dissolves in seawater. It's as simple as stirring sugar into your morning cup of tea. Once dissolved, the carbon dioxide doesn't just sit there. No, it gets busy, combining with water to form carbonic acid. But wait, acid in the ocean, you might ask? Yes, indeed. This isn't the kind of acid that you'd find in a car battery, but it's an acid nonetheless. This carbonic acid then splits apart, breaking down into bicarbonate and hydrogen ions. This process increases the concentration of hydrogen ions in the ocean, and as a result, the acidity of the ocean increases. Now let's talk about the pH scale. This is what scientists use to measure how acidic or basic a solution is. The scale runs from 0 to 14, with 7 being neutral. Anything below 7 is acidic, and anything above is basic or alkaline. When it comes to the ocean, even a small shift in the pH scale can have a significant impact. In fact, since the Industrial Revolution, the ocean's pH has dropped from about 8.2 to around 8.1. That might not seem like much, but remember, the pH scale is logarithmic, meaning this small change actually represents a roughly 30% increase in acidity. So, in plain English, what does this all mean? Well, it means that as we continue to pump carbon dioxide into the atmosphere, more and more of it dissolves into the ocean, forming carbonic acid and increasing the ocean's acidity. This process, my friends, is what we call ocean acidification. In essence, more carbon dioxide in our atmosphere means more acid in our oceans. So what does this mean for our oceans and the life they harbor, you might wonder? Well, the consequences are far-reaching, particularly for marine life that build their homes and bodies out of calcium carbonate. Think clams, coral reefs, and a myriad of microscopic creatures. As the oceans become more acidic, these shell-building organisms find it increasingly difficult to construct their protective casings and vital structures. Imagine trying to build a sandcastle as the tide comes in. It's essentially the same challenge these creatures face. They're fighting a losing battle, and as they disappear, so does the rich biodiversity they support. Coral reefs, often described as the rainforests of the sea, are particularly vulnerable. They host a quarter of all marine species. As the reefs disintegrate, it's not just the corals that suffer, but the entire ecosystem they uphold. The ripple effects of ocean acidification could potentially touch every corner of the marine ecosystem. Why should we care about ocean acidification? The answer is simple. Our survival depends on it. We rely on the ocean in more ways than we might realize. It's not just about the millions of people around the globe who depend on it for their primary source of protein. It's more than the livelihoods of those in the fishing industry. The ocean plays a crucial role in our planet's climate regulation. It absorbs about a quarter of the carbon dioxide humans produce, helping to keep our atmosphere in check. But what happens when this balance is upset? Ocean acidification threatens these vital services. It can lead to the collapse of marine food chains, affecting fish stocks and the people who depend on them. It can disrupt the ocean's ability to regulate our climate, leading to more extreme weather events. Moreover, did you know that every second breath you take comes from the oxygen produced by oceanic plankton? If ocean acidification harms these tiny organisms, it could impact the very air we breathe. Ocean acidification isn't just an underwater problem, it's a problem for all of us.